Sen. Starting with a mechanical lathe machining, a steel billet, at extremely high rotation speeds. The expert is inspecting the brushless motor, preparing components for the high-power propulsion system, applying a protective primer spray to the boat's frame structure, with its previously shaped aerodynamic design, switching to an angle grinder to cut the plywood, shaping the contour of the boat's flat bottom. 3. Machining the rounded corners, requiring absolute precision for dynamic balance. Hand sanding to completely smooth the wooden surface, before wrapping it in load-bearing composite material, covering it entirely with a layer of fiberglass reinforcement net over the entire bottom surface of the board, using a roller to spread the epoxy resin mixture evenly with a hardener solvent onto the fiberglass mesh. The resin soaks in, binding the cross-fiber structure. Once dry, it will create an ultra-rigid outer shell. The floating frame structure, made of PVC pipes, is cut and firmly glued to the flat surface. These ribbed pipes help increase buoyancy volume and the hull's torsional rigidity. Flipping it over to the top side, continuing to lay down fiberglass mesh sheets, pre-cut to the exact contour, applying multiple small fiberglass strips to interlock and reinforce the horizontal and vertical ribs. The roller continuously spreads the epoxy resin evenly to completely eliminate trapped air bubbles, observing the composite shell gradually curing, forming a sturdy overall design structure, continuing to pour a thin layer of resin to create a maximum waterproof surface membrane. The mirror-like reflective surface shows that the fiberglass structure has completely cured, providing excellent load-bearing capacity. Proceeding to disassemble the motor unit, the brushless electric motor, to modify the drive shaft journal mechanism, the stator coils, and permanent magnet rotor core, with super strong magnetic force inside, are revealed. Mounting the shaft journal on the lathe for machining, to resize the coupling joint, to assemble the propeller set. 4. The lathe tool cuts the metal to create a precise positioning groove, ensuring a perfectly slip-resistant coupling. Beginning. Reassembling the motor cover and tightening the bolts, securing the shaft center concentrically, carefully sliding the rotor assembly back into the housing. The magnetic pull of the rare earth magnets is very strong. Manually checking the concentric rotation of the new shaft journal. It is completely ready to handle high RPMs. This is an ultralight carbon material propeller, with a wide blade specialized for airboat thrust. Tapping the threads of the bolt holes on the propeller hub using a potamanator, high-precision bench drill press. Centering the propeller on the motor shaft mount and installing 4 pieces of hex, high-strength bolts. 5. Tightening the bolts in a cross pattern ensures even force distribution, preventing cracks in the carbon fiber structure. The entire rear electric motor and thrust propeller assembly has completed its mechanical hardware setup. 1. Moving to the stage of bending and shaping plastic pipes, using specialized rotary heating press equipment. 2. Cutting and gluing to form a circular shape, to act as a protective cage, and direct the exhaust airflow for the propeller assembly. Continuing to wrap a thin layer of fiberglass, and applying epoxy around the cage rim, to maximize rigidity. 3. This duct fan rim not only provides safety protection, but also compresses the airflow, increasing thrust force. Mixing epoxy, gluing and fixing the load-bearing pipe frame base of the motor onto the fiberglass deck. 4. Thoroughly rolling out air bubbles at the V-shaped joints. This is the position that withstands massive forward thrust forces. The base is designed with a tilted angle to optimize the propeller's thrust angle relative to the water surface. 1. Using a pneumatic paint spray gun to evenly apply a silver-gray paint layer over the entire aerodynamic hull frame. 2. It needs to be sprayed thinly in multiple layers for the smoothest possible surface, helping to minimize air resistance. 3. The duct fan ribs are also painted in matching silver, completely covering the raw fiberglass layer. 4. Fastening screws to secure and mount the brushless motor into the X-shaped centering bracket inside the protective wind cage assembly. Assembling the carbon propeller onto the shaft, manually rotating it to align the minimum clearance between the blade tips with the rim. This narrow gap operates on the Venturi tube principle, helping compress the airflow and eliminate turbulence. 1. Prepare the rod end ball joints. To connect and start assembling the system. 2. The aerodynamic steering mechanism. Set up the push-pull age system. Connect the steering shaft to the tail rudders. Behind the fan, the lever mechanism, the transmission lever, directly redirects the steering force from the front handlebars. 3. Securely tighten the ball joint bolts. The mechanical age system moves very smoothly and accurately. 4. Install the 2 giant dual air pushing fan shrouds onto the main mounting brackets. Use locking pliers to hold them in place. Use a wrench to tighten the nuts on the transmission tie rods. Close-up shot of the rod end ball joints connecting the A-arm steering, which is highly flexible. 4. Connect the gold-plated bullet connectors for the phases of the 3-phase electric motor. Brushless. 5. Introducing the LCD screen that measures the voltage and discharge current of the battery, a high-power lithium battery. Install the ESC for handling heavy loads, fixing it right onto the aluminum motor casing. 6. Connect the mini water cooling pump system, using heat-resistant silicone tubes to circulate the coolant. 7. The circulating cooling water tank is cleverly installed behind the shield, pumping directly into the ESC water jacket. The cool water runs through the aluminum radiator before returning to the tank, thoroughly cooling the system. The handlebar steering mechanism moves smoothly, ready to redirect the angle of the rear dual pushing fans. Assemble the high-discharge LiPo battery pack, carefully heat-shrink wrapping the XT90 connector for waterproofing. 1. The basic electrical system is complete. Plug in the connector to activate the main power board. 2. The telemetry screen lights up, displaying the standard voltage parameters. The propulsion system is ready. The engine roars. The propellers tear through the wind, creating extremely strong static thrust. Right on the shore. Launch the homemade airboat into the sea. The anti-sink pontoon design takes effect. Gunning the throttle, the dual propellers provide reactive thrust, pushing the boat forward to glide powerfully. The flat-bottom design helps the boat cut through the water easily, avoiding hydrodynamic friction drag. Point of view shot from the driver. The steering handlebars are highly responsive, accurately redirecting the fan's airflow angle. The composite frame demonstrates excellent stability when gliding over lightly rippled waves. The high RPM brushless motor, combined with the water cooling system, continuously operates perfectly. The side angle shot shows the impressive gliding speed of this mini airboat that was homemade. 4. The thin, lightweight hull combined with massive thrust creates an ideal power-to-weight ratio. 5. Successfully completed the sea trial test. The equipment operates smoothly, without any minor glitches. 6. Transition back to the workshop to start a new project. Measure and sketch the dimensions on the plywood. 7. 1. Use a handheld jigsaw to quickly glide through, cutting the wood along the pre-drawn outline. 2. Highly professional curved cutting techniques. Create perfectly matching hull panels. 3. Cut a large flat-bottom panel. This will be a traditional flat-bottomed wooden boat. 4. A panning shot highlights the sharp, precise sawing action as the wood fibers are cut to shape the boat's bottom form. Temporarily stand the wooden panels to form the hull, preparing for the gluing and assembly stage. Apply resin-based glue vertically along the dough panel joints to shape the initial structure. Introducing a roll of fiberglass mat, original fiberglass mat, ready for the composite wrapping step. 1. Spread the fiberglass mesh to fully line the inside of the wooden hull, to reinforce its load-bearing capacity. 2. Evenly brush the pre-mixed epoxy resin onto the fiber mesh. The resin soaks in and turns white, creating an ultra-durable layer. 3. Erect the 2 side hull panels. Fit and accurately position the chamfered bow angle. Continue, applying fiberglass strips to reinforce the V-shaped corner joints. For absolute waterproofing, let the epoxy soak evenly into all the crevices, enhancing the solid bond of the plywood structure. Move on to the benchtop scroll saw. Rip cutting thin wooden strips to make reinforcing ribs. 4. Place the wooden ribs, pre-cut horizontally across the hull bottom, to distribute the braking force. 5. Brush epoxy resin over the ribs to cover them completely, firmly bonding them to the fiberglass hull bottom. 6. Continue to overlay fiberglass strips diagonally across the surface of the wooden ribs. Install small support blocks along the hull with epoxy resin, locking the load-bearing structure securely in place. To assemble the deck boards to cover the bow, edge the margins with fiberglass strips to lock the diagonal joints. Apply resin and smooth out the edges, ensuring there are no air bubbles that could weaken the structure. Apply fiberglass powder along the hull side for protection, preventing tears by pressing it firmly with a roller. Use an angle grinder to trim away the excess wood and fiberglass protruding from the sides. Mount a flap disc on the grinder to smooth out the entire outer surface of the composite hull. Meticulously hand sand the narrow edges and hidden corners to create a rough surface. In preparation for painting, the fully cured fiberglass hull creates a hydrodynamic wave-piercing design. The process of applying decals and removing masking tape reveals sharp outlines. The green, yellow, and red trim lines running along the hull are meticulously detailed. The overall look of the boat, after finishing the painting and coating, exudes a strong traditional boat style. 4. The spacious cockpit with raised wooden ribs increases load distribution and prevents slipping. The boat's deck is perfectly flat. The center mounting base is perfectly balanced for the hull. Transitioning to introduce the miniature RC fishing boat model, equipped with a solid brass propeller, preparing 2 lead-acid batteries, with large capacity to provide a continuous discharge current, launching the real boat and the RC model boat into the canal, preparing for the towing test. Hook the tow line from the stern of the model fishing boat to the bow of the composite boat. Lower the heavy batteries into the boat, set up, and connect the model's propulsion electrical system. 4. Clamp the battery terminals securely. To ensure the voltage to the electronic speed controller doesn't drop, 2 men sit on the heavily loaded boat and begin to activate the remote control. The RC boat throttles up and accelerates, the propeller churning the water into white foam. The tow cable is stretched to the max. Incredible power. The tiny model boat is effortlessly pulling the boat carrying 2 people. The brushless motor transmits power through the propeller shaft. The torque overcomes the massive hydrodynamic drag. 4. Gliding extremely smoothly on the water. The payload of hundreds of kilograms doesn't stall. The miniature motor. 5. A close-up shot of pulling the throttle trigger on the remote. Radio waves steer the servo smoothly. 6. The RC boat cuts through the water, creating a V-shaped wake. The underwater rudder steering system responds sensitively. C. The aerodynamic design of the composite boat's bow glides over the water, cutting through waves optimally to minimize towing resistance. The real-world test proves the cooling performance and the stable discharge current of the systems. A wide shot covering the entire canal section. The unique towing scene by a model boat attracts everyone's attention. The front passenger uses a hand paddle to assist with gentle steering, corrections when navigating around narrow bends. The towing system passes through the large fishing boat anchorage, still maintaining an extremely stable RPM. 4. The miniature tugboat continues to cross the area where large fishing boats are anchored. Woo! The pulling force from the 3-phase brushless electric motor remains incredibly strong and continuous. 6. The camera angle mounted on the boat's hull shows the stability of the drivetrain and the underwater propeller. 6. The tow line is always kept taut, proving that the water resistance of the composite boat is immense. The front passenger leisurely puts down his paddle, fully trusting the miniature boat's pulling capability. High torque helps the device cut through waves easily, without overheating the electronic speed controller. The front mechanic even lies back and relaxes on the deck, while the system is still running. Large capacity lead-acid batteries, providing abundant energy for the travel distance, which is very long. The rear view shows the miniature boat's bow cutting through the water, creating a very even V-shaped wake. The underwater rudder steers extremely sensitively, according to the radio signal from the handheld controller of the person sitting. The composite boat glides smoothly, On the blue water, heading deep into the boat mooring area. The circulating water cooling system. Inside, the tugboat is working at full capacity to dissipate heat. The mass of hundreds of kilograms of two adults is completely subdued by the micromechanical system. A controller continuously fine-tunes the steering angle to avoid floating obstacles in the mooring area. Two super strong electromagnetic motors show no signs of exhaustion or dropping. Shaft rotation speed. 3. The controlling mechanic releases the throttle, slowly reducing speed when approaching the crushed stone embankment, right at the water's edge. 4. Close-up of the squeezing and releasing action of the throttle trigger on the transmitter to control the boat's drifting inertia. 5. Excellently completing the heavy load towing test. Realistically on the water. For the equipment, two mechanics recover the green tugboat and disconnect the cable to prepare for the next step. 6. Switching to a first-person view directly from the boat's bow as the model glides alone on the water. The bow, painted with colorful streaks, splits the rippling waves, creating a visual effect. The boat's center of gravity is extremely well balanced, preventing the bow from dipping down or lifting too high when running. The powerful water jet from the propeller hits the rudder, creating very flexible cornering capabilities. The entire hull structure is absolutely waterproof, safely protecting the electronic system inside. The moving speed without the load of the towing cable of this miniature boat is truly impressive and amazing. Two mechanics row the large composite boat parallel to track the steering trajectory of the model. The panoramic view of the boat gliding among dozens of giant fishing boats that are firmly moored. The size, contrast, highlights the smooth operation of the microdrive system. The miniature fishing boat model is pulled up onto the large boat's deck with the structure of the propeller shaft clearly exposed. Moving on to testing the operation of the model. Fishing boat with a light blue hull that was newly built. This second version glides fast on the calm lake, leaving behind a trail of white foam. 3. The dynamic balance capability of the hull when making sharp turns at high speed is truly excellent. The pointed bow, combined with extremely large static thrust, helps the tiny machine tear through the wind and rush forward. 4. The camera placed directly on the blue boat's bow records the entire view of the narrow waterway along the embankment. 5. The sunlight reflects brilliantly on the water surface as the boat accelerates straight ahead. 6. A direct camera angle placed right on the pointed bow of the blue miniature boat. The static thrust from the rear propeller continuously pushes this aerodynamic design, gliding forward. 7. 3. Sudden acceleration causes the boat's bow to lift up, making white foam splash onto the lens. The excellent dynamic self-balancing capability helps the thin, light hull avoid flipping over when encountering waves. The three-phase brushless motor still maintains an extremely stable and smooth high RPM range. A compact boat cuts through the water, heading straight into the harbor area, where countless large fishing boats are moored. 2. The operator makes a sharp turn with the underwater rudder via radio waves from the handheld controller. 3. The trajectory of the brob, extremely sharp turn, proves the sensitivity of the drive mechanism and electronic steering. 4. The circulating water cooling system, helping the electronic speed controller to avoid reaching excessively high temperatures. The first camera angle glides past the hulls of giant fishing boats made of sturdy wood. The fully waterproof hull design safely protects the high-capacity battery pack. The abundant discharge current from the battery helps the motor constantly achieve maximum propulsion torque. It continues to weave through narrow gaps between moored boats, thanks to an extremely small turning radius. The flat and smooth deck boards help minimize air friction and drag when running at very high speeds. The bow continuously cuts through waves, creating two separate streams of water along both sides of the hull. The blue boat is approaching the shore, passing the marked stone embankment, preparing to conclude the test run, gradually reducing the propeller's rotation speed to utilize coasting inertia, bringing the model close to the shore. A wide camera angle transitions the scene to a spectacular performance by a fleet of boats, controlled remotely. 3 miniature boats, including the blue boat, the gray boat, and the red boat, showcase their mechanical power together. The most prominent is the patrol boat with a metallic gray hull, featuring an enclosed deck design optimized for aerodynamics. The hull's curved edges are smoothly rounded, helping the floating hull glide effortlessly across the waves. Next to it is the bright red miniature fishing boat, which is also at full throttle, spinning in circles. All 3 devices operate completely independently through 3 separate channels of radio control frequencies. The blue boat makes extremely sharp steering turns, creating a powerful swirling vortex of water. A panoramic high-angle shot captures the entire high-speed chase between the gray and blue boats. The 2 propeller systems, spinning at maximum RPM, tear across the water's surface, leaving behind 2 thick, white wakes. The precisely scaled design provides perfect water-cutting capabilities, rivaling those of a real boat. The 2 miniature machines speed toward the port, concluding a highly successful fabrication project.